Look at your hands. Feel the weight of the air on your skin. Listen to the sound of your own breathing, the quiet rhythm that confirms your place in the world. You are here. You are now. But what does that truly mean? What is this place you call here? Is it the room you are in? The building? The city that spreads out like a circuit board of sleeping lights? Is it the continent, a vast shape of rock and soil cradled by oceans? Or is it this planet, this sphere of blue and white, spinning silently in a bath of solar wind? This lonely, lovely outpost of life in a solar system of silent giants and frozen wanderers. We have always been a species of explorers. It is woven into the very fabric of our being. We climbed out of the valleys, we crossed the oceans, we looked up at the moon and felt not a sense of boundary, but a sense of invitation. The sky was never a ceiling. It was a destination. And so, the dream was born. A dream of starships, of journeys that last for generations. A dream of charting the spiral arms of our own galaxy, the Milky Way, and then, in some distant, magnificent future, leaping across the black, silent void to the shores of another. To Andromeda, to Triangulum, to the countless smudges of light that pepper the deepest photographs of space. The universe, we told ourselves, is our inheritance. All of it. An infinite frontier waiting for our footprints. This is a beautiful dream. It is also a lie. Not a malicious lie. It is a lie born of perspective, a misunderstanding whispered to us by our own limited senses. We stand on our small world and see a static, eternal backdrop of stars, a celestial painting that never seems to change. We assume it will wait for us. It will not. There's a ghost in the cosmos, an unseen, relentless force that is actively working against that dream. It is not a monster, not an alien intelligence. It is something far more fundamental. It is the nature of reality itself, and it is pulling the universe apart. There is a boundary being drawn around us, even as we speak, a line in the cosmic sand. It is not a wall of fire or a barrier of matter. It is a horizon of pure geometry, a limit defined by the very expansion of space. This boundary encloses what we call the effectable universe. It is the sum total of everything we can ever hope to touch, to influence, to reach, no matter how advanced our technology becomes. This is the story of our true cosmic inheritance. It is a story not of infinite exploration, but of profound isolation. It is the story of our future, a future defined not by how far we can go, but by a line we can never, ever cross. Ask yourself again, what is this place you call here? Because here is becoming smaller every second. To understand this cosmic prison, you must first unlearn what you think you know about space. You must abandon the simple, intuitive notion of an empty stage on which actors like planets and stars move about. That is the world as Isaac Newton saw it, a grand, predictable clockwork. But the universe, we discovered, is far stranger, far more alive. Our journey into this new reality begins not in the far future, with gleaming starships, but in the past. It begins in the early years of the 20th century, with glass photographic plates and the patient, lonely work of astronomers in cold, quiet observatories. At that time, we were still arguing about the size of our own cosmic backyard. We knew of our galaxy, the Milky Way, this river of stars that spills across our night sky. But there were other objects, faint, blurry patches of light called spiral nebulae. What were they? Were they infant solar systems, swirling into existence within our own galaxy? Or were they something far more staggering? Were they entire galaxies themselves, island universes, as the philosopher Immanuel Kant had once speculated, floating in an abyss of unimaginable scale? The question hung in the air, a profound debate about the very architecture of existence. Are we the universe, or are we just a tiny part of it? The first clue came not from a picture, but from a spectrum of light. An astronomer named Vesto Slipher spent years meticulously capturing the light from these spiral nebulae. He passed their faint glow through a prism, breaking it down into its constituent colors, a rainbow barcode that revealed the chemical makeup of the object and, crucially, its motion. He found something strange, something unsettling. The light from nearly all of these nebulae was stretched. Its spectral lines shifted toward the red end of the spectrum. This is redshift. It is the Doppler effect for light. Just as the pitch of siren lowers as it moves away from you, the wavelength of light from an object moving away from you stretches, becoming redder. Slipher's discovery was a whisper of a profound truth. Almost everything was moving away from us, and the fainter, presumably more distant, nebulae were moving away faster. It was as if we were at the center of a cosmic explosion. But this observation alone was not enough. It was a motion without a map. To understand the scale of this exodus, we needed to know the distance to these objects. We needed a cosmic yardstick. That yardstick was delivered by a woman whose name is not as famous as it should be, Henrietta Swan Leavitt. Working at the Harvard College Observatory, she was one of the Harvard computers, a group of women hired to catalog and measure the brightness of stars on photographic plates. It was meticulous, often tedious work. But in that work, she found a key, a secret hidden in a particular type of star called a Cepheid variable. These stars have a peculiar quality. They pulse, growing brighter and dimmer with a precise, reliable rhythm. Leavitt discovered a direct relationship between the period of that pulse and the star's true, intrinsic brightness. This was the breakthrough. Imagine you are in a dark field, looking at candles. You see a dim candle and a bright candle. Which one is farther away? You cannot know for sure. The dim candle might simply be a smaller flame up close. But what if you knew that all the candles were, in fact, identical 100-watt light bulbs? Then their apparent dimness would be a perfect measure of their distance. Section Henrietta Leavitt had found the universe's standard candle. By measuring the rhythm of a Cepheid's pulse, astronomers could know its true wattage. By comparing that to how dim it appeared from Earth, they could calculate its distance. The universe suddenly had depth. It had scale. Now the stage was set for the final act of this first revolution. The pioneer who would connect the motion to the distance was Edwin Hubble, a charismatic, ambitious astronomer working at the Mount Wilson Observatory in California. Using the most powerful telescope in the world at the time, he hunted for Cepheid variables within the Andromeda Nebula. In 1923, he found one, and then another. He did the calculations. The numbers were staggering. Andromeda was not a cloud within our galaxy. It was nearly 1 million light-years away, an island universe in its own right, as vast and brilliant as our own Milky Way. The universe was not one galaxy. It was billions. Our home had just shrunk from being everything to being an infinitesimal speck in a sea of countless others. But Hubble didn't stop there. He took Slipher's redshift data and combined it with his own distance measurements for dozens of galaxies. In 1929, he published a paper that changed human thought forever. The relationship was clear, undeniable, and shocking. The farther away a galaxy was, the faster it was receding from us. This was not a random scattering. This was a law. The universe was expanding. Think about what this means. It is not that the galaxies are like bits of shrapnel flying through a pre-existing static void. That would imply a center to the explosion, a single point from which everything is moving. But the universe has no center. Or rather, every point is the center. The correct way to visualize it is to imagine the fabric of space itself is stretching. The classic analogy is a loaf of raisin bread rising in the oven. Pick any raisin. As the dough expands, all the other raisins move away from it. The raisins nearby move away slowly, while the raisins on the far side of the loaf move away much faster. Every raisin sees the same thing. There is no special raisin. You are a raisin. The Earth is a raisin. Our galaxy is a raisin in a rising loaf of space-time. This simple, elegant idea demolished the static, eternal cosmos of antiquity. The universe has a history. It has a dynamic, evolving story. And if it is expanding now, it means that in the past, it must have been smaller, denser, hotter. It means there was a beginning. But it also implies something far more troubling. It implies a future governed by this relentless, irresistible expansion. This is the ghost we spoke of, the quiet, constant stretching of reality. It is not a force you can see or feel. It operates on scales so vast that it is utterly invisible to our daily lives. The gravity of our sun easily holds our planet. The gravity of our galaxy easily holds its hundreds of billions of stars. But between the great clusters of galaxies, over the chasms of millions of light years, the expansion wins. It is the patient, inexorable tide of the cosmos. And this tide is setting the boundaries of our destiny. Let's return to the dream of interstellar travel. It is a dream fueled by a simple, powerful equation. Speed equals distance over time. If we want to go far, we just need to go faster or travel for longer. We imagine ships powered by fusion, by antimatter, perhaps by physics we have not yet even conceived. We imagine ships that can approach the ultimate speed limit of the universe, the speed of light. At 10% of the speed of light, a journey to our nearest stellar neighbor, Proxima Centauri, would take about 42 years. A manageable, generational journey. To cross our entire Milky Way galaxy would take 1,000,000 years. A daunting, but perhaps not impossible, task for a civilization with a very long view. But what about the next galaxy? Andromeda is 2.5 million light-years away. Even at the speed of light, a journey that is fundamentally impossible for any object with mass, the trip would take 2.5 million years. And this is where the expansion of the universe begins to matter. It begins to rewrite the rules of the game. While our hypothetical ship is on its 2.5 million year journey to Andromeda, the universe is not waiting. Space itself is stretching. The good news for this particular journey is that Andromeda is part of our local group of galaxies. We're gravitationally bound to it. In fact, our two galaxies are on a collision course, destined to merge into a single, larger galaxy in about 4.5 billion years. So, Andromeda we can reach. We will reach it, whether we travel there or not. But what about the galaxies beyond our local group? What about the Virgo cluster, a collection of over 1,000 galaxies, some 54 million light-years away? Here, the problem becomes acute. 54 million light-years is the distance to the Virgo cluster now. But by the time a ship traveling at near-light speed arrived, the cluster would be much farther away. The space between us, and it would have stretched considerably during the 54 million year voyage. It's like trying to walk up a downward-moving escalator. Your own speed is constant, but the surface you are walking on is moving against you. And the farther away your destination, the faster the escalator is moving. The rate of the universe's expansion is described by the Hubble constant. The current value is roughly 70 kilometers per second per megaparsec. A megaparsec is a unit of distance equal to about 326 million light-years. This means that for every 326 million light-years farther away you look, a galaxy is receding from us 70 kilometers per second faster. A galaxy 10 megaparsecs away is receding at 700 kilometers per second. A galaxy 100 megaparsecs away is receding at 7,000 kilometers per second. A galaxy 1,000 megaparsecs away is receding at 70,000 kilometers per second. Do you see where this is going? There must be a distance at which the speed of recession, driven purely by the expansion of space, becomes equal to the speed of light. That distance is approximately 144 billion light-years. This is the cosmic horizon. Any galaxy that is currently beyond this distance is receding from us faster than the speed of light. Let that sink in. It is not moving through space faster than light. That would violate Einstein's theory of relativity. The galaxy itself is sitting relatively still in its own local patch of space. But the space between that galaxy and us is expanding so fast that the total distance is increasing at a rate faster than light can travel. This changes everything. This is not a technological barrier. This is not a problem we can solve with a better engine or a faster ship. You cannot outrun the expansion of space itself. It is a fundamental limit baked into the geometry of the cosmos. A photon of light emitted today from a galaxy beyond that horizon, a photon traveling toward us at the absolute cosmic speed limit, will never reach us. It is like a swimmer caught in a current that is stronger than their fastest stroke. They swim toward the shore with all their might, but the river carries them ever farther out to sea. They will never make it. The light from those galaxies is lost to us forever. We can see them now, but we are seeing their ancient light that was emitted billions of years ago when they were much closer to us. The light they are emitting right now will never arrive. We are watching ghosts. This creates a profound and chilling division of the universe into two categories: the reachable and the unreachable. The reachable universe is the set of all galaxies that we could, in principle, reach if we left today in a ship capable of traveling arbitrarily close to the speed of light. Because of the accelerating expansion of the universe, driven by a mysterious force we call dark energy, this boundary is much closer than the cosmic horizon. The current estimate for the edge of our reachable universe is about 18 billion light-years away. This sphere contains hundreds of billions of galaxies. It is a staggeringly vast dominion. But the full observable universe, the sphere of all light that has had time to reach us since the Big Bang, is much larger, about 465 billion light-years in radius. This means that we can see galaxies that are already, and have always been, utterly beyond our grasp. The vast majority of the galaxies we can see in our deepest telescopes, the most distant smudges of light, are part of a universe we can look at but never touch. They are cosmic mirages. Their past is visible to us, but their present and future are sealed off from ours. This is the genesis of the effectable universe. It is the portion of reality that we can, even in theory, ever interact with. It is our true cosmic home, and it is shrinking. The expansion of a universe is not constant. We have discovered that it is accelerating. This acceleration, powered by dark energy, is like turning up the speed on that cosmic escalator. It is actively pushing galaxies over the horizon, one by one. Every second, galaxies that were once reachable pass over that boundary and become forever inaccessible. We are losing our universe. Imagine a great library containing all the books ever written. But the library is on fire. Not a hot, raging fire, but a slow, cold fire of expanding space-time. We are in one wing of the library, and we can see the other wings, filled with books of unimaginable wisdom and beauty. But the corridors connecting the wings are stretching faster and faster. We can run. We can send out messengers. But there is a point beyond which the corridor is stretching faster than our fastest runner. The books in those far wings will be lost to us. Their stories will unfold and end, and we will never know them. This is our situation. We are living in a burning library. What does this mean for the future of humanity or any intelligent life that might arise? It means that our expansion into the cosmos is a race against time. Let's imagine a future human civilization, one that has mastered interstellar travel within our own Milky Way. We have colonies on thousands of worlds, a network of cultures spanning 100,000 light-years. We decide to launch our first great intergalactic voyage. We build a colossal ship, a world unto itself, and we send it toward a galaxy in the Virgo cluster. What happens? The journey is long, millions of years. Generations are born and die on the ship. They remember Earth only as a legend, a sacred myth. Their destination is a cloud of stars that grows imperceptibly brighter in their sky. But as they travel, the universe continues its relentless expansion. The space between their home galaxy, the Milky Way, and their destination galaxy in Virgo is stretching. If they travel fast enough, say at 999% of the speed of light, they might make it. They will arrive in a galaxy that is now much farther away than when they started. They have successfully crossed the void. But now a new problem arises. Communication. How do they talk to home? A message sent back to the Milky Way, traveling at the speed of light, now has to cross a much larger, and still growing expanse. The delay in communication could be tens of millions of years. A single hello and its reply could take longer than the entire evolutionary history of the human species up to this point. Meaningful conversation is impossible. Trade is impossible. A shared culture is impossible. The colonists have not just traveled to a new galaxy. They have seceded from our universe. They are now their own island, in their own causally disconnected patch of space-time. Their effectable universe is now centered on them, and it is a different sphere from ours. Some of the galaxies we can reach, they cannot. And some they can reach, we cannot. Now, imagine this process repeated over eons. Civilizations spread out from galaxy to galaxy, like seeds scattered on the wind. Each new colony becomes the seed for further expansion. But as they spread, the universe pushes them apart. Each civilization becomes trapped within its own local supercluster of galaxies, a gravitationally bound archipelago in a sea of unending expansion. Eventually, the expansion will accelerate to such a degree that even these local superclusters will be torn apart. In the far, far future, a trillion years from now, any given galaxy will be its own isolated island universe. An observer in that far future, living in what was once our Milky Way, would look out into the night sky and see nothing but the stars of their own galaxy. Every other galaxy in the universe would have been pushed beyond the cosmic horizon. Their light would be so redshifted, so stretched, that it would be undetectable. The universe would appear empty, static, and small. The evidence of the Big Bang, the cosmic microwave background radiation, would have faded to nothing. The evidence of expansion, the redshift of distant galaxies, would be gone. Future cosmologists in that lonely galaxy would have no way of knowing the true history of the universe. They would look out and conclude that their galaxy was all that had ever existed, a single solitary island of light in an infinite, eternal darkness. They would be born into a cosmic prison, and they would not even know the walls were there. The grand, sprawling, populated universe of a trillion galaxies would have vanished, its memory erased by the expansion of space itself. This is the ultimate consequence of the accelerating universe. The erasure of information, the death of cosmology, the great forgetting. So where does that leave us, here and now? We are living in a privileged moment, a cosmic dawn. We are alive at a time when the evidence of our origins and the true scale of our universe is still written in the sky. We can see the afterglow of creation. We can see the galaxies fleeing from us. We have the chance to learn the story before the book is destroyed. This knowledge places a profound responsibility upon us. Our effectable universe, this sphere of 18 billion light years, containing some 100 billion galaxies, is our ultimate inheritance. It is the clay from which our descendants can shape the future. It is vast beyond human comprehension. It is a canvas large enough to paint masterpieces for trillions of years. But it is finite, and it is all we will ever have. The dream of an infinite frontier is dead. In its place is a new dream, a more mature, more poignant one. The dream of being good custodians of our own cosmic garden. What does this mean for us practically? It means that every decision we make has cosmic significance. When we look at our own planet, this fragile, miraculous incubator of life, we must see it not just as our home, but as the seed from which a forest of life could grow to fill 100 billion galaxies. Section, if we fail here, if we extinguish the light of consciousness on this world through war or neglect or folly, we may be extinguishing the only chance for life to flourish in this entire sector of the cosmos. The silence of the universe is a terrifying thing. What if we're the only ones? What if this is the only seed? The responsibility is almost too great to bear, but it is also a source of immense purpose. Our future is not about conquest. It is not about planting flags on every moon and planet in every galaxy. It is about the careful, deliberate spreading of life, of culture, of knowledge, of beauty, throughout our reachable sphere. It means we must think on timescales that are alien to us, not in years or decades or even centuries. We must think in millennia, in millions of years, in billions. We must become architects of deep time. The first step is survival. We must ensure the continuity of our species and of the precious biosphere of our home world. This is the non-negotiable prerequisite for any cosmic future. The second step is expansion within our own solar system, creating redundant outposts of humanity on the Moon, on Mars, and the asteroid belt. This is our insurance policy against a single-planet catastrophe. The third step is the long, patient journey to the stars, sending robotic probes first, then perhaps, one day, generation ships carrying the frozen embryos of Earth's life or the digital blueprints of our minds. This is not the swashbuckling adventure of science fiction. It will be slow. It will be difficult. It will be driven not by glory, but by a sacred sense of duty to the future. And with every step we take outwards, we must be mindful of the growing silence behind us. Communication delays will stretch from minutes to years to centuries. Each colony will, by necessity, become culturally independent. We will not build a monolithic galactic empire. That is a fantasy born of a misunderstanding of space-time. Instead, we will become a diaspora, a family of civilizations scattered across the stars, each unique, each evolving on its own path, bound only by the common memory of a pale blue dot. Perhaps the goal is not to maintain a single humanity at all. Perhaps the goal is to create a diversity of post-human cultures, a Cambrian explosion of consciousness adapted to 1,000 different worlds. The effectable universe is our canvas. Life is our paint. What will we create? Will we spread conflict and destruction, painting our cosmic neighborhood with the gray ashes of our own self-destructive nature? Or will we spread art and science and compassion? Will we fill the silent worlds with music? Will we write new philosophies in the light of alien suns? Will we build societies that last for 1 billion years, dedicated to exploring the nature of existence and consciousness? The choice begins now. It begins with you. It begins in how you see the world. Do you see a collection of separate, competing interests? Or do you see a single, interconnected planetary civilization, the crew of Spaceship Earth, on its first, most crucial voyage? The accelerating expansion of the universe is a somber, beautiful truth. It is a cosmic memento mori, a reminder that our time and our place is finite. It tells us that most of the universe is, and always will be, beyond our reach. A silent movie we can watch but never join. But it also tells us that what is within our reach is precious beyond all measure. The 100 billion galaxies of our effectable universe are not just a scattering of matter and energy. They are a promise. They are the potential for a future so grand, so rich with life and experience, that it beggars the imagination. This is our cosmic legacy, not to conquer infinity, but to fill our finite corner of it with meaning. To become the loving custodians of our own unimaginably vast and achingly beautiful cosmic garden. To look up at the night sky, not with a sense of longing for what is beyond our grasp, but with a sense of profound and overwhelming gratitude for what is within it. This is our home. This is our future. It is all we have, and it is more than enough.